Everyone, and welcome to day 2 of lesson 9.1. Today we are going to talk about classifying quadrilaterals based on their sides, lengths, and their angles. So a couple things of review before we get into this lesson. Reminder with slope, there is positive slope when a line is increasing, negative slope when a line is decreasing, slope of horizontal lines is 0, slopes of vertical lines is what we call undefined. And I always like to remember this by my little acronym SlopeMan, because you have negative slope, positive slope, vertical lines have undefined slope, and horizontal lines have 0 slope. So we have that little face to kind of remind us of that. And oftentimes what we do to find the slope is we either subtract the y values of our coordinates divided by the x values of our coordinates subtracted, or we can just count if we're given the graph, rise over run. Now, this also leads us to the idea of parallel versus perpendicular lines, because remember, if lines are going to be parallel, their slope is the exact same. They are never going to intersect each other. They rise and run the same amount, versus perpendicular lines are what we call opposite reciprocals or negative reciprocals. You flip the sign and the fraction, and they will intersect to create right angles specifically. So if we look down here in some of these examples, let's start off by calculating some of these slopes, as well as determining what would be the slopes of parallel and perpendicular lines. Because we have on this first one that the line, if we count, we have a positive slope for sure because it's increasing, and then we are rising 2 and running 6. So we know our slope would be rising 2, running 6, or 1 over 3. Now this leads us then to what would the slope of a line parallel to that be? Well, same exact thing, 1 over 3. Perpendicular slope then would be an opposite reciprocal. So we flip the sign to now be negative, and then instead of 1 over 3, we would have 3 over 1 or just 3 on that one. The next one then, if we look, this is going to be an example of a decreasing line, right? We are going down, so we know our slope in this one is going to be negative, and then we're going down 3, and then to the right 3 as well. So when we go down 3 to the right 3, we end up with a slope of negative 1, which means a slope of a line parallel to that would again be the exact same. It would have to be negative 1, and the slope of a line perpendicular to that is going to be its opposite reciprocal. So flip negative to be positive, 1 over 1 actually will still stay 1 over 1. Now, in our last example, we are not given a picture, but we are given our x values and y values. So we can calculate our slope by subtracting. So I'm going to take my y values, 17 and 8, and I'm going to subtract those, and then do the same thing with my x values. Subtract those. So 17 minus 8 is 9. Negative 11 minus negative 11 is the same thing as saying negative 11 plus 11, which is 0. Well, anytime we are dividing by 0, okay, what happens to our slope is it becomes undefined because we cannot divide by 0. This is actually just going to be an example of a vertical line, which means the slope of a line parallel to that is also going to be undefined, right? Because that would also be another vertical line. Its slope is undefined. The slope of a perpendicular line would have to be that of a horizontal line, so its slope would end up being just 0. Okay, so that's kind of the unique thing about parallel and perpendicular for vertical and horizontal lines. All right, here is an example for you to try. You are going to first calculate what is the slope of this given line, and then what would be the slope of a line parallel as well as a line perpendicular. All right, now moving on to this next page, now that we've recalled some review of our slopes, we also want to recall some ideas of our quadrilaterals. Now, we talked about this last semester, but we have different properties of parallelograms, rectangles, rhombuses, squares, and trapezoids. The big thing being that our opposite sides in each of these are parallel as well as congruent for rectangles and parallelograms. Meanwhile, in squares and rhombuses, all 4 sides are congruent. In a trapezoid, we have one pair of opposite sides parallel. That's the important thing there. Now, something else that's going to differentiate our squares and our rectangles from the other two is the fact that we create these right angles here, aka the sides are perpendicular. So in this next piece, we want to graph and decide what kind of quadrilateral are we being given. So we have a point A at 0, 2. B is at 3, 5. C is at 8, 5. And D is at 5, 2. And if we want to find the side lengths, similar to what we were doing in the last lesson, we can start, for some of these, we can just count. Because for instance, from B to C, this is just 5 units, as well as from A to D, that is just 5 units. So those we know would just be 5. To find A to B or C to D, this is where we're going to have to employ a little bit of Pythagorean theorem or the distance formula. So one of these two options. I'm going to use Pythagorean theorem for this one, but to find my length of AB, I'm going to take A squared plus B squared, and then I will call that my C squared. So 9 plus 9 is 18. And if we square root both of these, AB is the square root of 18, which is about 4.2. Now notice C to D is also going to be 1, 2, 3, 1, 2, 3. So it's going to also have that exact same length of square root of 18, aka 4.2. Now the slopes, again, we are counting rise over run. So if we check out from A to B, we're rising 3, running 3. So rising 3, running 3, our slope is 1. Same thing from D to C, rising 3, running 3, also going to have a slope of 1. Now our two sides over here, BC and AD, they are horizontal lines. Remember, horizontal lines have 0 as the value of their slope. So what we're noticing on this picture is that all 4 sides are not necessarily congruent to each other, right? These are not all the same. And we do not have any perpendicular slopes. 1 and 0 are not opposite reciprocal. So the best name we can give this figure is a parallelogram. All right, let's try another example on the next page. Again, let's start off by making sure we graph P, this time Q, which is at 6, 6, R, which is at 4, 1, and S, which is at -1, 3. And we see this lovely little figure here. And now even just by looking at this, you might have your predictions of what this is, but let's double check. Now for the lengths of these one, none of these unfortunately are going to be able to be counted. But again, we can either use the distance formula or Pythagorean theorem and count. And we see that we have a rising 5, running 2. All of these are actually going to create that, but from S to P, we see this to start. So S to P, again, if you want to think about it as C squared equals 5 squared plus 2 squared. S to P squared equals 29. Square root 29. We find out that our side is about 5.4. Now what you're going to notice is if you draw in other little right triangles, this is still 5 and 2, still 5 and 2, still 5 and 2. So all of these sides actually end up being that same value of about square root of 29, aka 5.4-ish. So another square root of 29 is 5.4. So what we're noticing is that all 4 sides are going to be the same size. So this is narrowing us down to either probably being a rhombus or a square, right? Now we need to double check, are there right angles or not? So if we notice from S to P, we rose 5, ran 2. We also did that over here for S to Q. We rose 5, ran 2. Oops, off on that. Rose 5, ran 2. So 5 over 2 would be the slope for both Q to R and P to S. Now we have to be careful though when we are looking for the slopes of PQ and SR, because we go down to the right. So notice we have this decreasing down to the right 5. Same thing over here, decreasing slope from S to R down to the right 5. So when we compare -2/5 to 5/2, we flipped the sign and the fraction. So yes, these are going to be right angles because of these opposite reciprocals, creating those right angles. So inside of here, not only are all 4 sides equal, but we are creating 4 right angles. So this is an example of a square. We have one final example for you to try. On this one, you are going to start off by finding the side lengths of all 4 sides of our polygon, find the slopes, and then finally, what kind of quadrilateral would this be? Thanks everyone for watching, and we will work more with these in class.